Hey guys, once again welcome to the CAD tutorial series. Guys, in the earlier sessions, we had discussed about planning and modeling softwares. So now it's time to start with the structural designing softwares. Right, so this type of structures you have this before the actual commissioning of this structure. So that structural designing can be done with the help of STAAD Pro, ETABS and a lot of other softwares. So today we are going to discuss about STAAD Pro, or this entire course session will be of STAAD Pro. So STAAD Pro is basically it is a structural analysis and design computer program which was originally developed by the Research Engineers International, that is REI, and later on it was taken over by the Bentley Systems. So from then onwards it's known as Bentley STAAD Pro. The commercial version of STAAD Pro is one of the most widely used software for structural designing and analysis, that is known as STAAD.Pro. Now the workflow of this STAAD Pro software is basically divided into two parts, that is analysis and design. So what is analysis? Analysis is the determination of effects of loads on physical structure and their components, which can be simplified as, like, after the applied load we can check the internal forces like SFD, BMD, that is shear force, bending moment, deflection, displacement, the reactions generated which will be generated within the members or parts of the structure. So that is basically analysis, right, which we used to do theoretically in the strength of material subject, right? All of we have done this during our first year of engineering career, right? After that, the next process is design. So structural designing is the methodical investigation of the stability, strength and rigidity of the structures. So by definition it's like this. The basic objective in structural analysis and design is to produce a structure capable of resisting all applied loads without failure throughout the lifetime of the structure. So if we can simplify this, we can simplify like this. Suppose the members we are choosing in a structure, after the application of load, whether the members will be stable enough to withstand the load and whether the structural stability of the structure will remain throughout the lifespan of the structure, right? So these are few projects which we are going to cover within the course curriculum. So before starting with the actual software, let us take a video demonstration. I'll give you a walkthrough on the course topics which we are going to cover through a video demonstration. So as we open up the software, we are going to get this type of an interface. Like these are the menu bars, different toolbars are there. I'll tell you about the interface later, right? So this is the structural modeling going on, right? Before the analysis process we have to do the structural modeling, the load application and all, which I'll show you one by one. This is actually one of the tools, translation repeat, by which you can repeat certain beams or columns, you can say, in structural terms. So you can repeat certain structures or parts of the structure, right? This type of models can be generated, right? This is another a structure wherein we are going to use this command 3D circular, or you can name it as circular repeat, wherein this member can be repeated in a circular pattern and a structure like this can be shaped, right? So after we are done with the modeling, that is, we have to apply the properties, the member properties, or the properties of the members. That is, you are going to apply steel properties or RCC properties or any other materials you want to add, that can be added. This is a 3D rendered view, as you can see over here. So this is the steel property applied, that is properly visible. Now another structural modeling I will show you. So this is the grid modification. The units of the grid can be changed. So this is the structural modeling. That is for a project, let us say for a building project, if we do the modeling part, this is first of all we are placing the beams and the joint points. The black color points can be considered as nodes, and the lines can be considered as beams, right? So we had just created the level 1. Now we have to create the other floors. So this is the entire modeling part that has taken over. So after that, again the same process, we have to do the property application, right? So this is the RCC property or concrete property, you can see over here. The definition of beams and columns are being defined. The RCC properties are being applied over here, right? Then we are going to see the 3D rendered view. Like this is the 3D rendered view, as you can see over here, right? So after that we are going to move to the load application part. So this is the basic load application on a particular member. So you can see UDL over here, point load, moment and uniformly varying load. So this type of calculations or this type of theoretical problems we had done in strength of material subject, wherein we are we got the results like this, the shear force diagram, bending moment diagram. We had to do theoretical calculations over there. So now basically the purpose of using STAAD Pro is to avoid those theoretical calculations and to generate the results with the help of the softwares, which I can we can see over here the diagrams with the maximum and minimum values which we use to get through theoretical calculations, and the theoretical values, the tabulated values over here, right? So software does or reduces the manual work, right? So suppose for a multi-storied building, let us say for this project, if we are going to apply the load theoretically, right, then it would have been huge time taking, right? So software actually reduces that effort and time. So this is the load application, wherein you can see the application of this uniformly distributed load on the walls, right? So for this particular project, the building project, the wall load has been applied, right? Then we can apply the live load, that is for the floor, that is through floor pressure we had applied, right? So this is where we have to give the range, that is the height of the structure. So after the application of load, we have to do the analysis process, that is we'll be getting the shear force, the bending moment, the displacement, each and other results, and then we are going to proceed with the design. So once the analysis is done with zero errors and zero warnings, we'll be proceeding to the post-processing part, wherein we are going to check the analysis results, right? From here, for the entire structure, for each and every members, all the values will be calculated by the software, which manually would have taken a much longer time, right? So the support reactions we have already seen, then the each and every shear force, bending moment, displacement on each and every members we are also able to see, right? The axial forces, each and every details will be visible. Now this is the graphical representation after the application of live load on the floor, individual floor, right? So if we do the analysis of a water tank, overhead water storage tank, then we are going to get a contour representation or a graphical representation of the stress analysis. This is the graphical representation of the stress analysis. Now this is an example of a water storage tank, RCC water storage tank, right? So these are the properties that are visible, the supports that are assigned, the properties had already been described, and then we have to move to the load part, right? So that is, this is the application of hydrostatic pressure. So the formula we already know, that is by the formula of rho gh, density of the fluid, the height of the tank, and the gravity value, that is g value. With the help of that, we are going to generate this hydrostatic pressure on the base plate and the side walls, right? This is an example of structural analysis. Now let us further discuss about the load application. So we'll discuss about the seismic load application. It will be there, the wind load application. So for now, let us start with this seismic definition, right? So we have to choose the country code from here, which will be preloaded. So once we choose this country code, that is 1893 2002 to 5, that is the seismic code. These are the seismic zones, like different states are being categorized under different seismic zones. So we have to choose those factors, right? These are the seismic parameters we can see over here. We are choosing the state, right? So we have to choose this soil type, response reduction factor. We'll be using this code from here so that to get the actual value, right? So after defining all these parameters, we have to assign the seismic parameters, right, on the structure, right? So this is the seismic weight definition that had already been done, right? So this is the application. So after this, we have to do the analysis. After the analysis is done, again we are going to check this results. So this is the animated portion. As you can see, after the seismic load application on the structure, the structure can be this type of animated structure. The structure can bend like this, right? So this is the application of the seismic load and the reaction forces that is being generated at different joint points. This is the graphical representation. Guys, now let us check the design result, that is the RCC design result, right? So for this particular structure, if we are going to check the design results for the beam and column, so this is what the design result actually looks like, wherein we are going to get the compressive strength of the concrete that is used, M25, Fe415 for both primary and secondary, the section properties, the area of steel in individual sections for both top and bottom, you can see over here, right? Yes, so this is the result of a beam. Next, we can see the reinforcement distribution as well. This is the bar distribution for top and bottom reinforcement. 4 12 mm dia of one layer, in the bottom 2 12 mm dia. The shear reinforcement, each and every details will be visible. Now if you want to check the cross section, this is the cross section part of a column, wherein you can see the bar size, number of bars, area of steel in both percentage and millimeter square, right? Fi, Fc, each and every Pu, that is the load, that can also be measured, right? So this is a beam section, right, wherein we can see the details in every three sections, the end sections and the mid span, right? So this was about the RCC design result. After that, we can shift to the steel design part, right? So this is the steel truss type of structure, as you can see, right? If you are going to check the design result of this steel section, wherein you can see for a particular profile the exact length of the profile used, the unit weight, then after the analysis and design process, the members which are getting failed and which are getting passed, that will be notified in the design result. So we can do some changes, the parameters, input parameters, we can do some changes. We can change the section property, or we can review the structure once again and pass the other structure which are getting failed. right? So that is actually the process. So now let us move to the foundation part. So once we are done with the analysis and design, we have to move to the foundation part. So this is the foundation part, the reactions which had been generated. We have to input those reaction parameters in the STAAD foundation. So this is the foundation system, right? The foundation design software, you can say STAAD foundation. This will get automatically installed with the STAAD Pro V8i SS6 software, which is being used. I'll be giving you the download link for that. So after we input the parameters, we apply the load and the other load combinations as well. We have to give this input parameters from here. We have to define whether we want to create an isolated footing or a combined footing or a raft type of foundation, right? So like this, we have to define the parameters. We have to give some input parameters for this rebars, right? So after we are done with this, we are going to get the result. So I'm going to show the result. The result will look like this, wherein you can see the bar details, the number of bars used, the dia of the members, and this is the theoretical calculation that has been shown. Over here you are also going to get the GA, the general arrangement drawing, and the details section or the schedule of the footings, right? So these are the details. This will automatically get exported to AutoCAD software, right? AutoCAD drawings can also be generated. So this was the GA. I'll show you once again, right? So after this schedules, this is the GA, general arrangement drawing, right? So this is all about the definition or a video demonstration about this STAAD Pro software. So these are the projects which we are going to cover up within this course curriculum. RCC structure, then few steel structures as well. This is transmission tower, water tank type of structure we are going to cover. This is again a RCC frame structure, or you can say like RCC building structure, right? This is the details of a beam section, right? Beam section, column section details. This is another live project which was done by our team. This is a tower, expansion tank tower structure. This tower is basically 20 meter of height. This was from a oil and gas industry, right? This is again a RCC frame structure, the 3D rendered view of that previous one, right? This is again a RCC frame type of structure. This is a steel structure. This was a industrial structure, right? So this is for a truss type or a shade type of structure, steel structure. It comes under steel structure category. Then we have this skid base frame. This is again a industrial type of structure. So you can see, right, we have a combination of both RCC and steel structure, so that students could gain some knowledge. And in this course session, we are basically going to cover up the live projects, so that whenever you will be working as professionals, it will be helpful for all of you. And these projects, if you are going to cover up within the course curriculum, so during the interview process, right, students who are fresher, I'm talking about them, during the interview process, you can produce this type of projects, right? So the interviewer, he can understand that you have done practical experience on STAAD, right? So this will be my advice. So yes guys, I hope you have understood about this STAAD Pro session, like what are the topics we are going to cover on this STAAD Pro software session, and what is the importance of learning this STAAD Pro software. So that's all for this session. We'll see you in the next video, wherein we'll start with the course session. Thank you.